Look at your hand. 5 fingers. Now look at a cat's paw. 5 toes. A lizard's foot. 5 toes. A bat's wing. 5 fingers underneath that leathery membrane. Even whales, dolphins and horses, which lost most of their fingers, started with 5. There is nothing magical about the number 5. Yet it is everywhere. Almost every land-living vertebrate on Earth has 5 digits on each limb. This is not a design choice. It is not the best possible number. It is an accident of evolutionary history. Welcome to Grossdenken, everyone. Today we are going to trace this story back 380 million years to a time when our ancestors had 8 fingers, and we will find out why 5 won. Please support this channel by just subscribing. It would mean a great help. The first animals with fingers were not humans, not mammals, not even reptiles. They were fish that crawled out of the water. And they had more than 5 fingers. Around 380 million years ago, the ancestors of all land vertebrates developed fingers while they were still mostly aquatic. These were the first tetrapods. The earliest tetrapod, Acanthostega, had 8 fingers on each hand. Other early tetrapods had 7 or 6. Number 5 was not special. In fact, the 5-finger pattern only became fixed later. For about 30 million years, the number of digits varied. As these early 4-limbed animals spent more time on land, gravity became a serious challenge. Their legs had to support weight, and the bones in their hands and feet had to change. The first functional 5-finger animal appeared about 348 million years ago, and it didn't even have 5 on both feet. One foot had 6, the other 5. So why did 5 win? Why not 4 or 6? The answer has to do with mechanical engineering and evolution. When early tetrapods walked on land, their weight pushed down on their wrists and ankles. This pressure caused the bones in their hands to rearrange. The inner and outer wrist bones shrank, reducing the area where fingers could attach. This led to the edge digits, the thumb and little finger, becoming smaller and eventually disappearing. This happened over and over in different lineages, but why stop at 5? Early tetrapods were amphibians. They still spent a lot of time in water. Fewer fingers meant less surface area for swimming. More than 5 fingers meant extra bones that reduced grip strength and made walking awkward. 5 was the sweet spot. Enough surface area for swimming, but not so many that walking was impaired. And importantly, fewer than 5 made digging and climbing less efficient for animals that needed to grip. The 5-digit pattern isn't just an accident of mechanics, it is also locked into our DNA. A family of genes called Hox genes control the development of our fingers and toes. Hox genes are the master switches that tell our embryo where to build the thumb, the index finger, and so on. In 2016, scientists discovered that a specific genetic switch involving the genes HOXA11 and HOXA13 was crucial to developing the 5-finger pattern. This switch emerged in early tetrapods during the transition from fin to limb. In fish, these genes overlap. But in land animals, the switch made them mutually exclusive. This separation in gene expression is the molecular basis for having 5, rather than more, digits. Mutations in these genes cause polydactyly, extra fingers, in humans and other animals. Here is the final twist. Once 5 became established, it was evolutionarily locked in. Adding a 6th finger turns out to be a huge disadvantage. A study of mice with extra toes found that their leg bones grew into an arc to accommodate the extra digit. The animals could not place their feet flat. They were forced to walk on their ankles, which severely affected their mobility and ability to survive. Animals can evolve fewer fingers. Horses walk on the tip of one finger, and birds have lost fingers. But adding an extra true finger is nearly impossible. Some animals, like pandas, have an extra thumb on the wrist, but this is a false thumb, a modified wrist bone, not a real extra finger. Frogs often have 6 toes, but this extra digit is formed differently, by extending the tibia bone, not by the normal mechanism of finger formation. So, why do we have 5 fingers? Because around 360 million years ago, a lineage of early tetrapods developed 5 digits, and that lineage happened to be the one that survived. Every other digit count went extinct. The 5-finger plan was good enough to support weight on land and maneuver in water. And once it was locked in by Hox's genes and the mechanics of walking, it became effectively permanent. The number 5 is not a design, it is an inheritance, a 350 million-year-old fossil frozen in our DNA. Thanks for watching and hit subscribe. Thanks for watching, and hit subscribe for more deep dives into the hidden history of life.